Hello dear students. Today we will study laws of crystallography. I am Dr. Sushmita Mandavgane, a faculty of chemistry department from DRB Sindhu Mahavidyalaya Nagpur. First, what is crystallography? It is a branch of science that deals with the geometry, properties and structure of crystals and crystalline substances. So we are going to study about a particular crystal through these laws. There are three fundamental laws of crystallography. The law of constancy of interfacial angle, the law of rationality of indices and the law of symmetry. The first law is the law of constancy of interfacial angle. This was given by Steno, a scientist. It states that the angle between the corresponding faces or planes forming the external surface of a crystal remains constant for a given substance no matter how the face is developed. That means whatever be the way of developing a particular crystal or formation of the crystal from different sources, but the angle, the interfacial angle between the corresponding faces will remain constant. For example, if we take the example of NaCl, though NaCl may be formed from different methods, but the interfacial angle between all the crystals which are formed from different methods will remain constant. The law of rationality of indices, this was given by Hui, and it states that the intercept of any face of a crystal along the crystallographic axis are either equal to or the unit intercepts of some simple whole number multiples of them. That is, the intercepts will be either equal to the unit intercepts or they will be some whole number multiples of the unit intercepts. For example, Na, N1b, N2c, where N, N1, N2, etc. are the simple whole numbers. In this particular figure, let OX, OY and OZ represents the three crystallographic axes, and let ABC be the unit plane. Then the unit intercepts are, suppose, small a, small b and small c. Now according to Hui's law, the intercept of a face such as PQR on the same three axes will be just a whole number multiple of these intercepts A, B and C. The next is the law of symmetry. This law states that the crystal of a particular substance always possesses the same elements of symmetry. Now there can be many types of elements of symmetry. The first type is plane of symmetry. It is the imaginary plane which can divide the crystal into two equal parts such that one part is the exact mirror image of the other. Then the crystal is said to have a plane of symmetry. So, there are 9 planes of symmetry in a cube. 6 are diagonal planes and 3 are rectangular planes. This is a diagonal plane of symmetry and these two are the rectangular plane of symmetry. Now the axis of symmetry or line of symmetry. It is an imaginary line about which, if the crystal is rotated such that it presents the same or similar appearance more than once during the complete revolution. That is, if we rotate the crystal through this particular axis of symmetry, we will see the same face for more than one time. So suppose if we rotate it, if we get the same appearance for 360 by n times, then the axis is called n-fold symmetry. Now, if it is a two-fold symmetry, then we call it a dyad. If three-fold symmetry, then we call it a triad. If four-fold symmetry, we call it a tetrad. And a six-fold symmetric axis of symmetry is known as a hexad. So see, this is a two-fold axis of symmetry. And this is a three-fold axis of symmetry joining the two opposite ends. Now the center of symmetry. Center of symmetry is an imaginary point inside the crystal such that any line drawn through it intersects the surface of the crystal at equal distances in both directions. So suppose this is the center of symmetry. So if we draw a line through this, passing through this center of symmetry, it will, the two distances up to the edges of the or the faces of the two sides of the cube, the distance will be constant or same. Now the elements of symmetry in cubic crystal. Now every crystal may have different numbers of each type of symmetry. If we take the example of a cubic crystal, then the elements of symmetry in cubic crystal is 23. There are 3 rectangular planes of symmetry, 6 diagonal planes of symmetry, 3 four-fold planes of symmetry, and 3 four-fold three-fold axis of symmetry, 6 two-fold axis of symmetry, and 1 center of symmetry. So a total is 23 different elements of symmetry in case of a cubic crystal. So this is about the laws of crystallography.